Hi, I'm Mr. Huber, and in this video we're going to have a look at another trigonometric equation. Cosine alpha is 1/2. Now, well, it's easy to work out because you use the arc cosine of 1/2. Set your calculator to degrees, so arc cosine of 0.5. That's now 60 degrees. Alpha is 60 degrees. Do we need a calculator for this? No, because we know this table by heart. We see if the cosine is 1/2, then the angle is 60 degrees when we work in the degree measure. Good, 60 degrees. Well, again, in year 4, this was enough. But not anymore. Maybe we do have more solutions. Well, in fact, we do have infinitely many solutions. So let's have a look at GeoGebra here. Now let's go to 1/2 or 60 degrees here. 60 degrees, 1/2. You see, your cosine is now 0.496. Well, because it's so fiddly, I can't do it in a better way. But well, let's just get close to 60 degrees. Yeah, here we go. So it's approximately 0.5. If I was able to hit 60 degrees exactly, it would be 0.5. So that's the red line. So do we have another point on this unit circle where we do have 0.5? Well, let's go over here. Well, it's the same length, but the problem here is now that's in the negative. But we could go over here. You see? Although the point is in the 4th quadrant and the y value is negative, the x value is positive. So that means it's 360 degrees minus the 60 degrees. So it's 300 degrees. So what does that mean? Let's quickly write this up. So you could say alpha is 60 degrees plus k times 360 degrees. Well, all the full revolutions. K is an element of z. And you could say the second basic solution is 360 minus 60 degrees plus k times 360. K is an element of z. So that would mean 300 degrees plus k times 360 degrees. Here we go. So these are the two solutions that give you in total infinitely many solutions. Well, you have infinitely many solutions here and you have infinitely many solutions here. Good. Let's have another look at GeoGebra. Here we go. Well, 0.5, that's what we want. Cosine must be 0.5, and we've seen it's 0.5 at 60 degrees. Okay. And it is 0.5. Let's just move this around a bit. And it's 0.5 at 300 degrees. Look, 300 degrees is in fact minus 60 degrees. So oftentimes we don't write what we've just written. We don't write 60 degrees and 300 degrees. We just do this. Cosine alpha is 1/2. Then alpha is arc cosine of 1/2, and our calculator or our table gives us 60 degrees. But then we say plus minus 60 degrees because it's symmetric with respect to the x-axis, plus k times 360 degrees. K is an element of z. This is one advantage if you write it like this compared to the sine exercise from before. The sine exercise from before, you have to write it like this. 30 degrees and 180 minus 30, and you get your two basic solutions. But here, you can write it as one line. with the plus minus as your basic solutions. And then you add your 360 degrees. Well, look, what does that mean? For example, k is equal to 1. With the first one, alpha is 60 plus 1 times 360. That would be 420 degrees. K could be minus 1. Alpha is 60 degrees minus 360 degrees. 1 times 360 degrees, that's minus 300 degrees. So where is this on our GeoGebra? Well, you have 60 degrees here. 60 degrees. Well, if you did 420, that would mean you go one whole turn plus 60 degrees. That would be here, 420 degrees. One full turn, you're here, plus 60, that's 420. And then you're obviously at 0.5. Or the other one that we've just mentioned, the minus 300 degrees, what would that be? Well, you go in this direction, minus 300 degrees. Well, then you're at 60 degrees. Minus 300 degrees, you're at 60 degrees here. And you get your 0.5. That's why you have infinitely many solutions to this equation. Why didn't we do this in year 4? Well, in year 4, we didn't do this because we worked in right-angled triangles. And in a right-angled triangle, look at this, you have a right-angled triangle here. Then this is 90 degrees, and these two angles must be less than 90 degrees, because when you add all angles up, alpha and beta, you should get 180 degrees. So it's because of the sum of the interior angles that the result that we get from our calculator was always the right one. But well, eventually we will have to deal with non-right triangles or more general triangles. And in there, you can have angles that are greater than 90 degrees. And later on, as we've just seen on the unit circle, you can have any angle you want. You can have 420, you can have 1748 as an angle. Okay, so that's just several full turns and something. Okay, so I hope it wasn't too difficult to understand. See you in the next one.